Welcome to aminacademy.com. In astronomy, let us discuss about seasons. What is season? A season is a period of the year that is distinguished by the special climate conditions. The four seasons, spring, summer, fall, and winter, follow one another regularly. Each has its own light, temperature, and weather pattern that repeat yearly. In the northern hemisphere, the winter generally begins on December 21 or 22. This is the winter solstice, the day of the year with the shortest period of the daylight. Summer begins on June 20 or 21, the summer solstice, which has the most daylight of any day in the year. Spring and fall or autumn begins on equinoxes, days that have equal amount of daylight and darkness. The vernal or spring equinox falls on March 20 to 21 and the autumnal equinox is September 22 or 23. The season in the northern hemisphere are the opposite of in southern hemisphere. This means that in Argentina and Australia, winter begins in June. The winter solstice in the southern hemisphere is June 20 or 21, while the summer solstice, the longest day of the year, is December 21 or 22. Many people have believed that the seasons were the result of changing distances between Earth and the Sun. This sounds reasonable at first. It should be colder when Earth is farther from the Sun, but the facts don't bear out this hypothesis. Although Earth's orbit around the Sun is an ellipse, the distance from the Sun varies by only about 3%. That's not enough to cause the significant variations in the Sun's heating. To make matters worse for people in North America who hold this hypothesis, Earth is actually closest to the Sun in January when the northern hemisphere is in the middle of winter. And if distances were the governing factor, why would the two hemispheres have opposite seasons? As we shall show, the seasons are actually caused by of the tilt of 23.5 degree tilt of Earth's axis. Earth's tilted axis causes the seasons, just we saw. Throughout the year, different parts of the Earth receives the Sun's most direct rays. So, when the North Poles tilt towards the Sun, it's summer in the northern hemisphere. And when the South Poles tilts towards the Sun, it's winter in the northern hemisphere. It's all about Earth's tilt. Many people believe that Earth is closer to the Sun in the summer and that is why it is hotter. And likewise, they think Earth is farthest from the Sun in the winter. Although this idea makes some sense, but it's incorrect. It is true that Earth's orbit is not a perfect circle. It is a bit lopsided. During part of the year, Earth is closer to the Sun than at other times. However, in the northern hemisphere, there were having winter when the Earth is closest to the Sun and summer when it is farthest away. Compared with how far away the Sun is, this change in Earth's distances throughout the year does not make much differences to our weather. There is another different reasons the Earth's seasons. The Earth's axis is an imaginary pole going around through the center of the earth from top to bottom. Earth spins around this pole, making one complete turn each day. That is why we have day and night, and why every part of the earth's surface gets some of each. What is the causes caused earth to tilt? Long, long ago, when earth was young, it is thought that something big hit earth and knocked off kilter. So instead of rotating with its axis straight up and down, it leans over a bit. That is a tilt axis. By the way, the big thing that hit earth is called Tia. It also blasted a big hole in the surface. That big hit sent a huge amount of dust and rubble into orbit. Most scientists think that rubble in time became our moon. Next one, we discuss about Earth's lopsided orbit. Earth's perihelion, that is point closest to the sun, nearly this much miles. 9 crores 149 9 crores 14 lakhs miles from the sun. Earth's aphelion point farthest from the sun is 9 crore 45 lakhs miles from the sun. The difference is this much. While that is a different over a 3 million miles relative to the entire distances, it is not much, because comparing the distance, this 3 million miles is not so much different. Look at this figure. This aphelion north farthest from the sun, it's aphelion, and it's a perihelion nearest to the sun. Little difference. And believe it or not, aphelion when Earth is farthest from the sun occurs in July, and perihelion when we are closest over the hour in the January. For those of us who live in the northern hemisphere, where its summer is July and winter in January, that seems backwards, doesn't it? That just goes to prove that Earth's distance from the sun is not the cause of seasons. Seasons and sunshine. How does the sun's favoring one hemisphere translate into making it warmer for us down on the surface of the earth? There are two effects we need to consider. When we lean into the sun, sunlight hits us at a more direct angle and is more effective at heating its surface. You can get a similar effect by shining a flashlight onto a wall. For example, if you shine the flashlight straight on, you get an immense spot of light on the wall. But if you hold a flashlight at an angle, that means if the wall leans out of the beam, then the spot of light is more spread out. Like the straight on light, the sunlight is more direct and intense in the northern hemisphere, and hence more the effective of at heating. The second effect has to do with the length of time the sun spends about the horizon. Even if you have never thought about astronomy before, we are sure you have observed that the hours of daylight increases in summer and decreases in winter. Let's look at what the sun's illumination on Earth look like at some specific dates of the year. When these effects are there, at their maximum on or about June 21, the date we who live in the northern hemisphere call the summer solstice, or sometimes the first day of summer. The sun shines down most directly upon the northern hemisphere of Earth. It appears about 23 degrees north of the equator, and thus on the day it passes through the zenith of the places on Earth that are 23° north latitude. The situation is shown in different figures. We can see that the sun's rays shine down all around the North Pole at the solstice. As Earth turns on its axis, the North Pole is continuously illuminated by the sun. All places within 23 degrees of the pole have sunshine for 24 hours. The sun is as far north on this date as it can get. Many early cultures scheduled special events around the summer solstice to celebrate the longest day and thank their gods for making the weather warm. This required, this required people to keep track of the length of the days and the northward trek of the sun in order to know the light day for the party. The situation is reversed in 6 months later, about December 21, the date of the winter solstice or the first day of winter in the northern hemisphere. Now, it is the Arctic Circle that has the 24 hours night and the Antarctic circles that has the midnight sun. So, these are so much differences in seasons in northern and southern hemispheres at the same time. So far we discussed about the seasons, how it caused, how it happened. We have done. Please subscribe our YouTube channel.